my love. So the lesson for this week is going to be split up into two different videos. The first video is going to be kind of a prerequisite review from I guess, the last couple years you've taken of math. So, if you feel pretty confident with the stuff I'm about to talk about, feel free to move on to the next video. If you do struggle with, maybe talking about polynomials, maybe just watch some clips, maybe skip through this first part. As I said before, that second video is more or less the Algebra 2 content. This is more of a review. So let's get started. So first thing I want to cover before we jump into polynomials is the concept of a monomial. So a monomial is a number, variable, or a product of numbers and variables. So for example, we could have just a number, we could have a variable, a product of numbers and variables. You could even see something squared. All that really matters is that you see just one term by itself. So for example, this 4 is by itself, x is by itself, 7x is by itself, and 7x squared. Binomials, trinomials, polynomials, we'll see those later on. I'm going to give you guys a few examples, but in the beginning, I just want to work with monomials, kind of get you guys used to the basic rules, and then we'll move forward. So our product rule, you guys have definitely seen this before. This is when you are multiplying something that has the same base, but different exponents. So although it's called the product rule, and we think product multiplication, which is what we see here with our little dot, what we actually do with the exponents is we add the exponents. So I'm going to be adding m and n. And again, m and n are just two random exponents. A could be a variable. So let's just give you a real concrete example. So for example, let's say we had x squared times x to the 7th. What we would do if I saw multiplication is add the exponents together. So 2 plus 7 will give me 9. My power rule. So my power rule is pretty simple. It's actually one of the easier ones to use. You will be multiplying your exponents. And you will be treating any kind of constant just like normal. So let's give this a try. So for example, let's say I had a to the m, and I'm raising it to the n. What I will do is I will multiply m and n. So let's give this a try. So I'm going to do, let's do 2x to the 7th, and let's raise this to the 2nd. So what I have to do is I have to distribute this little exponent to my 2 and to my 7. So I will have 2 squared, so 2 squared is 4, and I will also have to do 7 times 2 because with exponents we multiply. So again, with coefficients we raise it to the 2nd, with exponents we multiply. So 7 times 2 will give me 14. Okay, our quotient rule. So quotient, we are used to seeing quotients, it's just division. So let's say I had a to the m on top and a to the n on the bottom. It's very similar in terms of the product rule. So when we had multiplication, we added. So if we have division, we will subtract. So we will subtract the exponents. If, say, we had a coefficient in the front, we would divide the coefficients like normal. But in terms of the exponents, we will be subtracting. So we will have a, the one on top, minus the one on the bottom. So let's give you a cute example. So let's say I had 4x to the 7th all over 2x squared. So I would treat the coefficients in front like normal. So 4 divided by 2 gives me 2. And we know with exponents we need to subtract. So 7 minus 2 will give me 5. Okay, so let's talk about this negative exponent rule. If you had me in Algebra 1, you probably remember the jump, the line, and change the sign. So, you might think to yourself, Aaron TV, what are you even talking about? Well, you guys probably remember earlier in the semester where I talked about how pretty much everything we've been talking about, let's just say we had a 2x, is really just 2x over 1. right? So let's say that we were applying a negative exponent to this. What we would do is we would jump over this line, my fraction bar, right? And we would change the sign. So I would bring this 2x to the negative 1 down, and when I bring it down, it becomes just 2x to the 1. So again, that might be a little bit confusing to understand, but I promise you when you see a bunch of examples, it's going to make a lot of sense. This is actually probably one of our more simple rules. So what this looks like, I would have a base and a negative exponent, and we would just jump over the line and change the sign. So notice how, regardless of whatever I have, an a to the negative m, I am just jumping over the line and having a 1 on top. So let's come up with an example. So let's say I had x to the negative 2. I would jump over the fraction bar, and I would have to change the sign, so I'd have x to the positive 2. And now my zero exponent rule. You guys are pretty familiar with this. Anything raised to the 0 is 1. There is a special case. 0 to the 0 is undefined. So this kind of works with anything you could think of. Say I wanted to raise 1,000 to the 0 or 1,000,000 to the 0. It would always come out to be 1. Even if I had some variables and some exponents, if I raise everything to the 0, this will become 1. It's pretty cool. So let's try some examples. So before we get started, you guys are pretty used to seeing like the combination of like terms. So we can only combine things if they have similar variables and identical exponents, right? So we can only combine x's with x's, y's with y's, etc., etc. Okay? Things that match. That's what you want to think about. One thing I also want to talk to you about is the exponents will follow these rules, while the coefficients in front, you just treat them like normal math. They do not follow those rules, okay? So let's look at number 1. I have a multiplication problem, right? So I'm going to be using the product rule on my exponents, but my numbers in the front, I'm going to treat them like normal, right? So we have 5 times negative 7, which will give me negative 35. And now I want to work with my exponents, right? Well, we know we have the product rule here, so what I have to do is I have to add them. So x squared plus x to the 6, so 2 plus 6 gives me 8. And we're done. All right, let's look at number 2. So we have a power rule here, right? So I need to distribute this exponent to everybody. So, and maybe I'll just write this a little bit bigger. We had a 2 here. So I'm going to square negative 2. So negative 2 squared is 4. And we know when we have the exponents, we will be multiplying, right? So we have a to the 3rd times 2. 3 times 2 gives me 6. And we know if we don't really see an exponent, there's a 1 there. And 1 times 2 will give me 2. I'm going to bring down everybody we see right here. And now I'm going to treat the numbers in front again like normal. So 4 times 8 gives me 32. And I'm going to treat the exponents how I was treating them prior, right? This is the product rule. So I will be adding the similar variables. So I have a to the 6th plus a to the 1st. That will give me a to the 7th. And b to the 2nd plus b to the 9th. That will give me b to the 11th. And we are done. Okay, let's look at number 3. So I clearly will have a quotient rule for that first chunk. So let's go piece by piece. So I'm going to do this piece first. So 54 divided by 3 will give me 18. Again, I treat coefficients the same, right? They're just regular numbers. It's the exponents I really want to worry about. So with the quotient rule, I will be subtracting, right? So m to the 6th minus m to the 2nd will give me m to the 4th. And n to the 4th minus n to the 1st will give me n to the 3rd. And I'm just going to bring down the rest of this. So I got minus 10 m to the 4th, n to the 3rd. So what do we notice? They are like terms, right? So for example, I have the same combination of variables and exponents here. So when I have that similar combination, what I have to do is I'll keep the variables the same, but I will have to simplify the numbers in front, right? We have to simplify those coefficients. So 18 minus 10 will give me 8. All right, so let's look at number 4. There are a bunch of different ways to do number 4. I'm going to cover 2 ways. I'm going to show you the product rule way to do this and the quotient rule way to do this. So let's try the product rule way. And again, I like to always encourage you ladies to do, whatever way comes natural to you, whatever way you feel comfortable with. There's no one right way to do everything in terms of some of the math problems that we will encounter. So, keep up your flexibility in terms of thinking of different ways to solve these problems. So I'm going to start with the product rule, right? So we know that our coefficients are being treated like normal, right? So 2 times 10 gives me 20. And now with the product rule, we add the exponents, right? So 4 plus negative 7 gives me negative 3. But we have a negative exponent here, right? So what do we do with negative exponents? We jump the line and we change the sign. So what was once a negative exponent became a positive exponent in the denominator. So there's my first way and my correct answer. Let's try it with the quotient rule. Okay. So let's look at this. So I will do 2 times 10 just like I did before. So I have 20 k to the 4th. And we know that since we have k to the negative 7th, this will go in the denominator, right? So we will have k to the 7th in my denominator. We have 4 minus 7, which gives me negative 3. And since he's negative, he goes in the denominator. So again, that second step was just like we did before. And you see that since we have a bigger bigger exponent in the denominator, that is where my 3 ended up staying. I do prefer the product rule. I think the product rule is a little bit easier in terms of coming up with these problems. But some of you guys are visual, and I want to keep all your different methods open. So let's look at number 5. So we have another situation where we have to distribute an exponent, right? So I got to make sure I'm going to apply it to this guy, and this guy. So I'm going to do some scratch work over here. So 2/3, when we square 2/3, we have to square the top and the bottom. So I have 2 squared over 3 squared, which gives me 4 over 9. So I have 4 9s. And now we know with exponents we multiply, right? So I have r squared times 2, so 2 times 2 gives me 4. And 7 times 2 gives me 14. Times 1, 6, r to the 3rd, s. Okay, so all I did was just bring this down, and we distributed the exponent to that first chunk right here, right? So now I'm going to treat the numbers like normal. So I have 4 9s times 1 6. This gives me 4 over 54. And this actually simplifies to be 2 over 27. So I have 2 over 27. And now we know if we have multiplication, so if we have this little dot here, this is when I'm going to be using the product rule. So that means I have to add my exponents. So 4 plus 3 gives me 7. And 14, we know that there's a 1 secretly here, right? 14 plus 1 gives me 15. And feel free to pause these videos, try these problems. There's no reason that, you just need to copy everything that I'm doing. I know you guys can do this. You kids are smart. You can work through this. All right, so I have a negative exponent right here. So what does that tell me to do? I got to jump the line and change the sign. But this problem is pretty interesting. Since it's already a fraction, when I bring the 14w to the 12th down, I will also be bringing the 7th w to the 3rd up, right? Because you have to apply the negative exponent to the numerator and the denominator. So you have to jump the line and change the sign with both of them. So it actually just flips them, and it's pretty cool. So I'm going to bring this to the numerator, and I'm going to bring my 14w to the 12th to the denominator. I'm going to treat the numbers like normal. 7 over 14 is just a half, right? And now I have 3 minus 12 since it's the quotient rule. So 3 minus 12 gives me negative 9. Since she's negative, I'm going to bring her into the denominator. And there we go. So we are done. All right, let's look at 7. So I have 15 over 24. These are both divisible by 3. So I will have, let's see, 15 divided by 3 gives me 5. And 24 divided by 3 gives me 8. Beautiful. And I'm going to use the quotient rule with everybody else, right? So I'm going to be subtracting these exponents. So 10 minus 12 gives me a negative 2. And you know what, I'm just going to write that out for you and we can flip everything later. And y to the 4th minus 3 gives me just one y left, right? 4 minus 3 gives me 1, and 10 minus 12 gave me negative 2. Well, we know that if we have a negative, we have to bring that to the denominator. We got to flip, we got to jump that line, change that sign. So I have 5/8, a y stays on top, and this x squared has to go in the denominator. All right, 8. So I have to deal with the power rule, right? So there's two different ways to do this. You could simplify what is in the parentheses first and then apply the power rule, or you can just straight up apply the power rule, simplify later. So really whatever you guys want to do. So I'm just going to simplify it first. So I have one c on top, I have 2 on the bottom. So that's, I can take away one of those c's, right? And I will have the ability to rewrite this, make it a little bit cuter for you. Now we got to apply this exponent to the top and to the bottom, right? And now you'll see why I did that, because 1 to the 4th stays 1, right? And c to the 4th, we multiply, so that would be c to the 4th. And now we can take care of this part right here. So we have to distribute this exponent, right? So I'm going to apply it to the negative 3, and I'm going to apply it to c. And be careful, when you put negative 3 to the 4th in your calculator, you need to put negative 3 in parentheses, or it will give you, sometimes it gives you the correct sign, sometimes it does not, okay? So just be very, very, very careful. So we will have, let's see, negative 3 to the 4th, that will be 81. And we will have c to the 4th. And look how nice. This is actually going to be really, really cute. I'm just going to show you guys the long way so you can visually see it. 81 times 1 c to the 4th will be 81 c to the 4th. We have c to the 4th on the bottom. So what happens? C to the 4th and c to the 4th, they cancel out, right? But let's talk about, what does canceling out even mean? Like, you guys are so used to saying, that just cancels out, right? Well, the reason why we can say things cancel out is because, let me just write this in color, because this is actually, the foundation of what you guys talk about a lot of times, and some of us don't even appreciate why this happens. So c to the 4th over c to the 4th becomes what? 4 minus 4 is 0, right? So this is really 1. So when we say that things cancel out, they're actually turning into 1. And as we know, 1 times anything doesn't really change anybody. So that's why we can say comfortably, throughout your last couple of years of math, that, oh yeah, that cancels out. Well, it's not really canceling out, it's becoming 1. And that's one of those beautiful things in terms of learning and talking about math. So let's go ahead, let's do one more page. So give an example of 2 monomials with a quotient of negative 3n squared divided by m. Okay, so they want a monomial on the top, a monomial on the bottom. That will give you this as a result. Well, I need a negative 3, right? So what gives me 3? A lot of things, right? We could do 6 divided by 2. That's what I'm going to do. I'm just going to make it a negative 6, so it gives me a negative 3. And let's see, we want an n squared to be on top. So let's do, n to the 4th minus n to the 2nd. That will give me 2, right? And we want an m to be on the bottom. Well, I could just make it be a negative 1. So let's simplify this. So we know that negative 6 divided by 2 will give me a negative 3. When we have the quotient rule, we do 4 minus 2. That will give me 2. And m to the negative 1, we will be grabbing this, right? we will jump the line and change the sign. That will give me an m in the denominator. And please don't feel bad if you can't come up with examples, right off the top of your head. Please keep in mind I've been doing math for a very long time, and I'm very passionate about it. So, it might take you a couple minutes to come up with those examples, but I know you guys can do it. So we kind of flew through monomials. Let's talk about polynomials. So polynomials is the sum or difference of many monomials. So it's something that you've definitely seen multiple times before. Maybe you just didn't know how to classify them, and that's kind of what we're going to talk about right now. So the highest exponent of a polynomial is called the degree. And you guys have definitely heard me say that before. The standard form, and this is important, the standard form of a polynomial, you will always write with exponents in descending order. So what does that mean? It just means that the monomials with the higher degree, so the highest number, will come first. Something else I want to talk about that I saw you guys kind of struggle with a little bit throughout the year is, what do you do if you have multiple variables, right? Like, for example, on 11, we have A and B, right? So what you always want to do is you want to look in alphabetical order, and you want to find the highest degree. So for example, if I had A and B, I want to look at all of my A's and put the highest A first, okay? So let's try 10 first, and then we'll go to the ones with double variables. So we have negative k to the fifth minus 1 plus 8k minus 3k to the third plus 1/4 k squared. So what I'm going to do is I'm just going to look for the highest exponent. So I can see that 5 is definitely my highest exponent, right? So I'll have negative k to the fifth, and I'm just going to scratch them out. Who's the next highest? I would say k to the third. So I got minus 3k to the third. Scratch them out. Make sure you guys grab the sign that is in front. So for example, don't forget that it's a negative 3k to the third. Let's see, we got k squared, so that's who's going to come next. Scratch them out. Then I got 8k, then I have a negative 1. Perfect. So this is standard form. This is putting everything properly in order. Let's look at 11. So again, as I said before, you want to look at them in alphabetical order, right? So I have an A to the third right here. So even though he doesn't have a B, it doesn't matter. We want to find the variables in order with the highest degree. So I have my A to the third. I'm going to scratch them out. Now I have my next highest A is my A to the second, and he's positive. So I have 18 A to the second, B to the second. Scratch, 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 scratch. And I have two options left, right? Well, the 7AB is the only one with an A. He has more A's, so he's going to go next. And I have minus B squared. And let's do 12. So my x's come before my y's, right? So I'm going to look for my highest x. That's definitely right here, my x to the third. So I have 9x to the third y. Scratch, scratch, scratch. I have x to the second. Scratch, scratch, scratch. Plus 5xy squared, since this is my last guy with an x. And now I'm going to do the next variable that's left. So I have minus y to the fourth, and then I have my constant of plus 2. Okay. So let's talk about how to actually name these terms and these polynomials. So we did kind of mention before that we classify these by degree, but we will also classify them by how many terms you see in the polynomial. So let's fill out this table first so that you guys understand what we're working with. So the degree is really important. So for example, if I have a degree of 0, which just means I have no variables, this is called a constant. This will just be a number. So for example, I could have 6x to the 0, which really just looks like 6, right? Because we covered that this right here would just be 1, and he would disappear. A degree of 1 would be called linear. So that would be something like 6x. A degree of 2 would be a quadratic. that would be what we are very used to, right? My x squared. 3 is cubic, so 6x to the third. 4th is quartic, so this is 6x to the fourth. And 5 is quintic, and this would be 6x to the fifth. Now my number terms, these are also words that you guys have probably heard before. I have my monomial. This is just one term, so let's just say we had x. Let's make it like x to the fifth or something. Binomial would be for 2. Let's say we had like x to the fifth plus x to the fourth. 3 is trinomial. So let's just come up with 3 random things. And 4 plus polynomial. And I think you guys get the picture, right? We would just have 4 terms all smushed together. So let's start naming these, right? So first thing I'm going to do is I'm going to look at my highest degrees, and I clearly see that I just have one variable, right? So this will be linear. And since we have just 2 terms, this will be a binomial. Again, this is my first term, my second term. Oh, also something that I do want to point out, I don't think we'll have this problem here on the notes, but you always want to make sure, and I'm going to put a little star, and I'm going to put in color, make sure your polynomial is in standard form. So again, standard form just means in order, right? The degrees are in order. Make sure that you are following the alphabet correctly, you know. So let's look at 14. We have 5, 4, 5, 4, 1. Good. It's in order. So if we have x to the fifth, that will be quintic. And we have 3 terms, so this will be a trinomial. Let's see, 15, we just have a constant, right, because there's no variable. And it will be a monomial. 16 is x to the third, so this will be a cubic. And again, they're in order, right? So we have x to the third, x to the second, x, 15. So we have a cubic, and let's see, 1, 2, 3, 4 terms. So this will be a polynomial. "17, we're in order, that's perfect. So since our lead is squared, this will be a quadratic. And there are 1, 2, 3 terms, so this will be a trinomial. Okay, 18, x to the fourth, this will be a quartic. And since we just have one term, I know it seems like a pretty big term, but it is just one term. This will be a quartic monomial. And let's see, give an example of a cubic binomial. So cubic just means something has to be raised to the third. Binomial just means that we need 2 terms, okay? So I have, let's say we have x to the third, and we just need another term. And there we go, cubic binomial. Give an example of a linear monomial. So linear just means we are to the first, right? So typically you just see a variable. And monomial just means one thing, right? So here, linear monomial. All right, and I think that wraps up this first video. Look forward to the second video. I will be talking about how to add, subtract, multiply, and divide polynomials.